This is the K-Bot, the world's first truly open source humanoid robot from K-Scale Labs.
We're here today with Benjamin Bolte, K-Scale Robotics, doing open source humanoid robots. Yep. So pleasure to meet you, man.
Yeah.
Where are we right now?
This is our office and also house. So we all live together, kind of working on stuff 24/7. So
okay. Yes. Well, yeah, mind if we come in? Take a look?
Yeah, come on. Yeah.
Where are we relative to like Stanford right now? Like
about 10 minutes from Stanford.
10 minutes from Stanford? Okay.
Yeah.
Cool.
So
okay, so we got sick. What are these? What's going on?
The story was we were part of YC Winter 24. I got in by myself with nothing, and I wanted to make a humanoid robot. I was kind of watching the ecosystem unfold after I was at Tesla. I felt that this was important, and so this was the first robot that we made. We called it Stompy because the feet are very big. This was basically to learn about how we could make humanoid robots, just get an understanding of the hardware supply chain and ecosystem. Partnering with a company called Robstride Dynamics, they make actuators that are good, low-cost actuators, and built this version, which is the first version of our sort of mass manufacturable open source robot. This is 20 degrees of freedom, very similar to this one, sort of optimized for reinforcement learning. So, but basically the point of this one was just to kind of figure out if we could get a thing that would be manufacturable, learn about the whole, factory ecosystem, and then, test out the software, make sure the voltage, the electronics, all works. Just make sure that we had a robot that was functional. And then we finished this one in November last year, and now we started on basically the sort of product ready version of the robot, which I think we have in here.
Yeah, and so from my understanding here is, classic, Palo Alto style startup house. This is actually the office, from my understanding, the office part where people working on stuff.
Well, Wesley is working in there. Some people work in here. We sent JX up here because he's very high entropy, I guess. We took you up here because you were making too many distractions for people. But we did actually a bunch of assembly for the smaller robot up here. This was the first Z-Bot, the 3D printed robot. And so, we just built this just ourselves with parts that we have here. And then this, maybe Jax could talk about.
It's like a side project. When we started, it was just we have this really cool, our reinforcement learning tools that we made. There's a bunch of software framework we made. Let's just put it on a really accessible robot. So we made this fully open source robot with 3D printed PLA parts.
Yeah, total price is $350.
Yeah. So we launched it on Twitter. It got pretty viral, and it went even more viral on WeChat. And then, so a lot of people just came in. It's I want to buy one. Different labs on it. So we eventually made the second version. Some of these prototypes that you see on the table, we're currently working on. We're trying to launch this month.
So give me a rundown. You went through YC. You're basically talking to the guys and you say, hey, listen, I know you've heard of robots before and you've seen a lot of robot companies where, me and my friends live together in this house and we're building robots and we're making it all open source. So that means my understanding is we're basically publishing the stuff openly.
Yeah.
And we're going to be really big by doing that. Is that roughly the pitch, or how did you basically come in and talk to these guys? Because it's a very, we know how much B2B SaaS they fund every batch. It's a very different take you guys have.
Well, so the story was actually, I was working on another startup before. It was kind of a speech startup for call centers in India. It was a very B2B SaaS idea. I was the CTO. I really found that this was not I didn't wake up every morning excited to be doing that. And I also had this feeling because I have a pretty impressive resume from Tesla, Facebook, Google, whatever.
Yeah, walk me through that a bit too, because I want to hear more about let's maybe walk me through kind of your career, and then let's get back to this point of how did you end up on this idea?
Sure. Yeah. So I started, so I was in college. I kind of I don't know. I interned at Amazon, Google, and Facebook because I was very corpo. And then I after college, I went to Facebook and I joined the AI research team. So it was like 2018. I was at like FAIR working on speech representation learning. Published a couple of papers. One paper that I worked on actually got really viral. It was like called Hubert. It was a paper for we used it for like voice modification. So like you hear a lot of like Kanye West like singing Hey There Delilah type dubs. Actually, most of those are based off of Hubert.
And like I know there's the Jordan Peterson ones. I actually think I was working on a text to speech voice startup a couple of years after like the Tacotron era, and so you've got overlapped on your work.
Yeah, Hubert was like just really good like speech tokens for voice generation. It was not originally for that. We were using it for we were investigating it for like low resource ASR. But then the speech tokens turned out to be really useful. Like working on Hubert was really fun. I didn't particularly like speech in general, so I went to after that and some other stuff at FAIR. And it was mid-COVID, and then Andre Karpathy from Tesla, his recruiter reached out to me. He was like a huge hero of mine for the longest time. I read his blogs when I was like in college, so I was in COVID. I didn't like working remotely. Tesla was in person. It was really exciting. So I decided to go work at Tesla. Was working on the autopilot team for before Optimus was released. So Optimus kind of came out in the middle of when I was at Tesla. But I worked mostly on the V11 release with my friend Patrick. We did the autoaggressive lane markers, like the sparse lane graph model. And then so that was really cool. It was like kind of first like end-to-end model. I did some CUDA stuff. Optimus came out with the like dancing guy, and I got to see like the back end, like behind the scenes for the Optimus development. It was really awesome. One of the models I worked on actually was like the first model we put in Optimus. It was like this like voxel occupancy grid model. Like a lot of overlap. Andre left Tesla, and then shortly after that, I was like weird politics stuff. I felt like after Andre left, I was not as happy there, so went back to FAIR to work on the robotics research team in New York. Facebook is not a great place to do robotics, so I felt very like isolated and wanted to work on something. That was kind of, I left FAIR the second time to do a startup. I was working on this speech startup, kind of based off of the Hubert stuff. I'm not like a huge like speech enthusiast personally, but it was, so after that, I realized I could probably get funded for something just based off of my resume. And so I was like, well, what do I actually believe in? And the only thing I really believed in was that, like, first, humanoid robots are the best platform for embodied AGI. And if they are going to reach mass adoption, they have to be open source just because of the nature of the product. And sort of from those two kind of points, I was like reasoning backwards to, okay, well, if those things will end up being the case, like, first of all, that there will be 1 billion humanoid robots. And second of all, that if you have a robot in your house, it is kind of by nature going to have to be like open source mostly, because you have to be able to trust it. No one was really building an open source humanoid robot company. I felt like I could probably build a robot myself, and YC accepted me for whatever reason. I think YC accepted me because good resume, that's kind of how Kscale got started. Basically off of the premise that like I don't think there's a future in like closed humanoid robots, and even if VCs are funding this today because of whatever reason, I think that in the long term, people will want an open source humanoid robot. And in the long term, that is what Kscale, that's why Kscale will sort of ultimately win in the space. And, we just have to stay alive until then and sort of prove that's the case.
So I think it's kind of, cool is like, even if you look at like Elon's companies, like they own the hardware. They're very like proprietary, like how you build a Tesla or you build one of their humanoids. And so investors are very like kind of RLHF'd into thinking about investing in closed everything, because that's like where the IP is. What's been like, how are you able to basically explain to people that there's a path here? by being like, hey, we're going to start open and just like.
Well, frankly speaking, investors in Silicon Valley know very little about hardware supply chain. So in fact, I think that is a common view, is Tesla is this vertically integrated company. But in fact, Tesla uses mostly consumer off-the-shelf components, like commercial off-the-shelf components. And Tesla's kind of value as a company is that it takes those fairly generic components and adds a software layer that makes it really valuable. So in fact, like that's why I was so excited about Autopilot for us, because it's like long-term cars are basically a software product. And I think like that's why I'm excited about humanoids, is that it's also eventually a software product. So even though it feels like, I think that it's just, frankly speaking, I think I have the best conversations with Chinese VCs because they're a lot closer to the ecosystem. Like you can tell now there's dozens of humanoid robot companies in China. They're fairly commoditized, and it's well understood that the long-term value from this type of product will be in the software. So yeah, Tesla is building their own cars, but they're actually doing it in a fairly commodity way. Yeah.
So you're making a bet that basically the hardware layer is going to get commoditized essentially on the robotics front, and then like is my understanding correct there?
No, it's actually, it's not such a bet. It's already happening. Like if you look at Tesla's supply chain for Optimus is now mostly through Asia. Like a lot of the components they're now sourcing outside of, like they're not building all these components themselves, nor should they. Like it's a smart decision. Even figure, all of the big players, like most of their supply chains are fairly distributed. So K-Scale is kind of just the maximalist version of that, where like if you really do project out 10 years, like humanoids are not so different fundamentally from like any consumer electronics product. Like Android phones are made by dozens of different companies, and the market penetration is quite high for Android phones. There's really no reason why humanoids will end up being any sort of different.
Cool. Well, I'd love to continue our kind of walkthrough of like what are the different. Give me a tour of like what are the different robots that you've been working on and the people working on them. You can meet gentlemen over here and just kind of give me. I'd love to do a walkthrough where we end downstairs in front of the main robots, and then kind of give me a tour through, ideally in chronological order would be cool. And I'll ask some questions there.
Yeah, this is where we do stand-ups every morning. Nice. So this is the latest version of the robot. This is the one that we want to start selling soon. You say this is this is another iteration that we built a while ago.
How many of these like what does an iteration mean in terms of guys, and like what's the time scale of that?
Yeah,
these are like whole ass robots you basically build.
The goal was really to like learn as much as possible so that we can build a good robot. I think the lesson from a lot of hardware startups is that the first 3 hardware iterations are basically not good, and I didn't want to sell something that's not good, so I had to like figure out how to get as many hardware iterations done before we start selling it. And that was the idea with the 3D printed one, is like, so this we fully CAD'd this ourselves. It's not great, but yeah, fully CAD'd it, built the electronics out. This is even a different type of actuator from this one. This is the same Encos motors that that you saw in the booster robot. It was just to learn about like what actuators, but again, like this would have been like probably like $20K price point just because of the same issues with the booster one. But yeah, it was just like a full CAD. We had like sort of set up the teleoperation setup for this one too, because it's got some cameras as well. But then this one is like basically, like this is like the final one. You can take off the head. So it's a lot more modular. Like we have the head is basically a standalone thing that we put cameras. It's literally a Raspberry Pi in this one, and on the back it's just like 24 volt power and a USB. So basically, the robot itself is a USB device with a battery to power peripherals.
Does that cause any like bandwidth issues, like USB?
Actually, no. So that's kind of the thing about doing like low cost robotics is that like with Tesla, the Tesla original BOM was about 20K, and it kind of ballooned. I think they're trying to sell it for like 100K or something, just because they really focus on this really good like high quality control. They're using EtherCAT. This is like EtherCAT is a good example of like why doing low cost robotics is different from doing more expensive.
What is EtherCAT?
Okay, so there's basically 2 common motor control protocols. EtherCAT is just a Ethernet based protocol, so you just like cat cables, like, and it runs very quickly. It's very like you get nanosecond latency for the control, and so EtherCAT, like some actuators, like will have EtherCAT on them, so you can like control them very easily. But if you look at any Chinese robot, none of them use EtherCAT, and the reason is that each of these ICs on the motors for the EtherCAT is like $100. It's pretty expensive, and you have to do a bunch of shielding stuff to get like high, like very like high bandwidth control. So this robot and most Chinese robots use like CAN bus. It's like automotive standard, and the timing is like less precise. Like
is that like control area network?
Yeah.
Okay.
Yeah, it's what most cars use.
Yeah.
It's actually very reliable because it's like it's like a differential pair signal. It's like fairly reliable, but the bandwidth is much lower. But so this robot, the max bandwidth for the control is about 100 hertz per motor, but you do a position control on the actuator. You learn it all in sim. You can actually account for this, and that's kind of what. Like that's why Unitree is able to get these really impressive demos with a fairly low cost robot, is because they just focus on having the price be low from the start, sort of solve it in software. And
interesting.
And so we do the same thing. So the USB cable from the head, it talks to the EtherCAT. It talks to the CAN bus board on the back. You can turn around if you want.
Yeah, sure.
Oh, this is just a power board. We have the CAN board. It's underneath. Yeah, exactly.
Interesting.
Yeah. Like the USB bandwidth is not a problem.
Cool. Okay. Now we're in
in the garage.
We're in the core.
Yeah. This is the reactor. Yeah. So this is the latest version of the robot as well. We have a few others. So yeah, because the total cost for us is pretty cheap, we can get a bunch even though we're not like, huge company. So yeah, like the idea is like we start with something that's pretty low cost and try to make it work better instead of starting with something that's like high cost that works well out of the box. And then you have to bring the cost down later. I think this is a much more principled philosophy, just because like we can just get a bunch, like, in this case, we've actually had some hardware failures, like it's just kind of breaking stuff off of the gantry. But in the end, it's like, it's like faster iteration cycles.
So if you guys are building, you have the hardware here, do you have to build like, and you're basically trying to get more people to like use these, do you guys have to build the whole developer like SDK layer and like the kind of like ROS essentially?
Yeah, we built out like basically all of the firmware for the robot as well. And after we had kind of built it out, because what we're really focusing on is basically running end-to-end neural networks on the robot. We wanted to have a very low like overhead toolkit to actually try things out. So you can go to our GitHub. It's all public. Like, nice. And just
we'll link to that. Help me walk through. So I think there's a lot of people watching might be, robotics enthusiasts, maybe from they're a kid. Maybe it's like the Mindstorm, maybe it was like in university. If somebody's getting involved with like K-scale robots, like what do they expect to be different than, robotics architectures from 5-10 years ago?
Yeah. So the thing about humanoids is it's 20 degrees of freedom. So it's pretty different from if you want to get a humanoid to do something useful, you can't just like write some sort of low level controller as easily. Even just getting a humanoid to walk is pretty difficult. So, but we still wanted to preserve that kind of very like low overhead, easy to use developer experience. So from the perspective of if I'm like getting started with a K-scale robot, you plug in a USB cable, it exposes a gRPC server over static HTTP. So you can install the Python SDK and start, communicating that way. Like what you really, the developer flow for the full-size humanoid is more that you train a RL policy and then put that on the robot. It runs, sort of on the robot itself.
So like when I was doing robots in academia, I would spend like 6 months trying to tune the walking gait and it still wouldn't walk well. Like, am I looking at like a 6-month timeline now? Is it like, do I call pip install RL like K-scale and then like train, or like how does this look now?
I mean, it's a hard problem. Yeah, for sure. And the goal for us really is to like make that hard problem easier. And that's how we want to open it up to more people. So the way that we have our RL training is in Majoko. It's this repo called KSIM. So you can install it if you have a 4090 or something. Like you can just train a policy in about 6 or 8 hours.
Cool.
So our focus really, like, there's a lot of engineering work to get sim to real work. Sim to real is not a particular, like, training the policy is not particularly hard. It's just like a PPO thing. But if you want to get sim to real to work, you have to do a lot of like engineering. So you get like, so the CAD model, we designed it on Onshape, and we wrote our own kind of exporter, like munging the Onshape API to get like a very accurate URDF, and then converting that URDF to like Majoko. We had to do a bunch of tricks to make it like simulate well, but the simulation is fairly accurate. So then when you finally go train a policy, you do have to do some domain randomization on the like model, the policy you train, to make sure that it still fits for like the real world robot. But the general flow, I think, is pretty good. Okay.
Cool. Yeah. Who are these guys? Who's all sitting here?
Yes, that's Ali, JX, Aaron, and Dennis. So
what are these guys doing? I assume they work for you?
I view us as a work collective.
And so, like you said, okay, Kickstarter, like what does that mean for a robotics company? Like, I send some money and like a robot shows up at my door, or like, are you guys helping me build like a cleaning robot, or like, what is this? What does this look like if I'm like, I want this?
Yeah. So basically for Kickstarter, we are launching this robot. So essentially you can buy this robot product. We have like manufacturing set up you can buy this as a product on Kickstarter that will arrive at your door in like 4 months after we launch. We're gonna have like the same PyKOS system. You can train the same machine learning frameworks, and it'll be like a ready-made product. It's like in a nicely wrapped box.
And how long? So say I want to have like a cool, like I just want a robot walking around, like a basic use case or something. Like how long is my development process? Would you expect from me?
You have like, basically, I'm currently working on like a nice SDK, as the abstraction of the KOS system. So I'm currently working on like essentially voice to action systems. So it has a VLM running on the ZBot, and then you can say like walk forward. So out of the box, the robot should just power on, and then you can just say walk forward, it will just walk forward. And it can identify objects, have a conversation with you.
And what are you guys like, what are you most excited to see people build with this over the next few months? So you launch the Kickstarter, a bunch of people get the robot.
Yeah.
What do you want to see the community do?
Yeah, so like from our previous hackathons, like 200, 300 people showed up. I think a lot of it's like the features is like a lot of dancing, a lot of motion stuff, a lot of entertaining use cases, a lot of basically adding new cool machine learning models on this robot, like testing all the like new language models, putting on the robot. It's like person companion. Yeah, I mean the creativity is like endless here.
And is there like, am I sending you like training data, or how does like, is it like recording my home? Like, how does it work if I have a robot and I care about like how does the privacy and stuff work?
Yeah, so we have this like essentially this dashboard you use. You only give the data if you want to give the data. So it's like fully private. It's going to be all like on board or with a local system, and only if you want to contribute to like the.
Do we have a natural? And we have about 10 minutes left. Anyway, I'd say.
Okay.
Cool. So is the developer interface is basically Python, like for anyone?
Yeah, I can talk about it. Yeah. So basically, on the control loop that runs on the robots is all based in Rust. So we want it to be like, it's just a Rust binary. That's what Kscale OS is. With the gRPC interface to actually interface with the binary. But from the developer experience, so what Ali writes is basically just Python code. So you can see like both robots are being interfaced with pykos.kos. This is just essentially the SDK. And we specify the IP address, so that's how it's able to do it kind of remotely. You have the KBot, the KBot's that one, and then the ZBot is this one. But you just basically the SDK lets you read the joint positions from the small one and just replay them on the big one.
Cool.
It's just a Python code. I think this is just, and like from a developer perspective too, you don't have to install a bunch of like dependencies. It's just gRPC client, and you can pip install it, and it just kind of works. Is you just plug in the USB cable and it exposes the IP address. Eventually, like you don't have to even be plugged in if it's connected to like the Wi-Fi.
Cool.
So yeah.
So you're selling robots for $1,000. Like 20x cheaper than I've seen or used, and it's fully open.
Yeah.
How are you going to win as like a business? Like, what's the, like, I want to make money investing in this company. What is the like ROI to an investor? How does this make sense? Like to be able to get the money to build this in the first place?
So in the long term, robots will be the best platform for embodied AI. I think this is the case. And I think that a world with 1 billion robots is going to be a very different world from today. And so on a long enough time frame, I think that any kind of USD based investment in K-scale probably doesn't, like, returns on that will not be measured in USD. I think returns on this will be measured in like basically some fraction of a percent on the sort of Kardashev scale. That's what I view. On the short term, I think, frankly speaking, like, we're a garage startup working on humanoid robots, and we haven't raised $1 billion. And I think we've got robots that are as good as anyone else. And so I think that, that's what I would guess the valuation should be considered by. I think that in the limit, like, you would really need to think about, like, what does this look like when it's out in the world, and which company is best positioned to make that happen. You kind of have to have some imagination about what the future looks like. And in my vision of the future, I just can't see anyone besides K-scale sort of succeeding. So if you do want to invest in something that I think has a future, I would invest in K-scale. That's my pitch to investors.
Cool.
Yeah.
And so the way this would, a friend of mine, Gil, is doing like Extropic, has a very similar, like very like, just like Kardashev style pitch for, or maybe explain to people who haven't heard that term. What is that? What does that mean? What does this future look like?
Yeah. So the company K-scale Labs, our goal is to make a dent in the sort of net energy consumption by humanity. Actually, like, harness energy in a way that is sort of useful. And I think the best way to do that is by building intelligent machines. That's net good. Like, you can, like progress, civilizational progress is basically measured in energy consumption. Like, if you have like the ability to build more intelligence, like building more stuff uses more energy. And so you want to use more energy as a general principle, as a general metric. Like, if you think about, like, some type 1 civilization that's like basically, using the energy from a planet to, do something, that's like, it's a very like clear metric that civilization is doing better than one that's not. Like, you can't, like, if a civilization is not able to harness energy, it's like the capabilities of that civilization is fundamentally limited. And so the way to do that with robots is, like, you have robots that can self-replicate or, are generally intelligent, moving around the world. I think it by necessity needs to be open source and sort of like a product that all of humanity kind of owns together. Like, that is a way that you can sort of direct energy in a useful way. And, when you're sort of looking at the sort of non-Terran future, like, I think that that's like where things are headed. So yeah.
So is the K and K-scale Kardashev?
Kardashev, yeah.
Okay, cool. All right.
I think
K-scale,
right? Kardashev scale.
Okay, that just clicked. That's great. Okay.
Yeah.
Kardashev scale robotics. Okay.
Kardashev scale.
So out of like the long term, you push this out. Basically, we have all these like super smart robots. They're performing tasks. Are they basically on payroll with your company? Like, they're effectively, like, at what point are they just like citizens of society versus contained within the K-scale ecosystem? I know that's a very far out.
Like, in the very long term,
yeah.
I think that robots will sort of always be like very human. So K-scale Labs is the name of the company after I changed it, but the legal name is DPSH. It stands for Don't Panic, Stay Human. This is my shirt, because I like The Hitchhiker's Guide to the Galaxy. And basically, I think that, like, robots will, like, any kind of robot that you train on data from humans will be a very human thing. And I think the reason people are excited about humanoids and more than other types of robots is because humanoids are human. They feel very human. And I think that, like, there's a world where I just don't think there's like going to be this like robot uprising at any point. I think that basically robots will be like kind of our descendants in a way. They're like trained on our data, living in our environments, and they're just a product of us as like a civilization. So yeah, I think that like in a long enough time horizon, like there will be very intelligent robots that'll feel very human. They'll feel like their own agents in the world, but it will fundamentally be like kind of our kids in a way, our sort of like civilizational descendants. Yeah.
Yeah, it's a very like I feel like Kscale is like one of the most pure robotics companies. I have to always be careful of how partisan I am because I was in robotics for quite a while, and a lot of my friends are in robotics. But I feel like this is the very pure Silicon Valley like robotics play. I think it's safe to say in terms of just like garage based. It's like cheaper than competitors. It's open. You're going to win just by creating societal like momentum on the planetary scale. I don't think you can get much more like pure than that. So yeah, really great to chat with you, Ben.
Fundamentally, I will say that like at the end of the day, Kscale will win if people believe in this vision and want to buy an open source robot instead of a closed source robot. And personally, I bet on this because I personally would want to buy an open source robot, not a closed source robot. And I think that there's enough people that agree with me that will be the thing that kind of like sets us apart from like Figure or Tesla.
Yeah, I mean the fun part is the whole premise of the community that is watching this video when it's online is effectively that. So there's a very strong lean in. That's what we're hoping to grow more. The democratized intelligence community is effectively around making more actually open AI. So yeah, it's great to meet you, Ben. Thanks for letting us into your office, house, your work-life harmony.
The Kbot is launching in July for $9,000 for early customers.
And this is the Zbot, the first miniature end-to-end humanoid robot. You can get this on Kickstarter this month for $1,000.